Okay guys, welcome to part 21. This is probably going to be the last episode. Maybe I'll do a last one, semi-final something, I don't know. But I think this has come quite far and I'm starting to be quite satisfied with this. So there's still lots of things I would like to improve on this, but I have lots of things to do. So I'm thinking if you guys have been following along, then you can easily expand on this. Okay, so I did one thing off video. I actually managed to trash my project from last video to now, so I had to rebuild some things, but I got it back again. So what I was experimenting with was a little bit of tweaking for the light settings. So normally I think I had this set to, static, yes. And that means our shadows look like this. And I also added a little skylight. So if I don't have my skylight, how do I turn this off? Then things will look like this. So I added that just to give it a little bit more softness to the shadows, and then I added the light source. I set that to movable. That does this kind of stuff, so it's still a little bit blurry and so on. But I just wanted to test this out. It's not going to be used for anything in a real game, I think. Not at this point anyway. And then I set the dynamic shadow distance. Set that down to 1000, so I would get some more clean, sharp, crisp shadows. So that was what I did off video. So one thing we should talk about here actually is that if I take this and I clone it, move it to the side, then we'll notice that apart from mixing up, they have the same sway frequency right now. So one easy way of fixing this is to go to the material and add an offset to the stem, the material function thing here. So right now it's just doing this same time, speed, multiply, and direction. Everything is the same for every tree. But if we take the hang on a sec. Actually, let's do something first before I do that, because I had a point with this. I'm going to take this tree here and I'm going to merge that. And I'm going to remember to bake my vertex data. Did I just delete it again? Oh. So that is supposed to be, yeah, I think that's the one. Yes. Okay. So if I just copy this tree, this is the merged tree. I just copy that a few times and apply a little rotation, which you would normally do, or probably do this with the foliage tool. Then we'll get this, and they're all swaying the same way, which is kind of annoying. So back to the material function up here. I have a feeling I deleted something I shouldn't. Okay. Anyway, so we have the time. And if we add the the position offset. Position offset. And just add that. So instead we just take the time and then we add this position offset. Then they are going to be different for each. The starting point on the sinus curve is going to be different for each position of a tree. By the way, you will see that I keep having to compile my shaders. That's because I make changes to my material function. Some of these changes don't really require me to do a recompile. I'm going to show you in a minute how we can do that instead. But what you can see now is that the trees now, these here, they have each their own sway frequency, which might look okay, and it's currently, I mean, I don't care, they don't all move in the same exact direction and at the same speed, but in fact actually they do it currently, just out of sync, by the way. So anyway, if we take a look at the procedurally generated one over here, then we do have a problem. So here we have all kinds of madness going on, and I wanted to do it in this way, the order, because I wanted to say something about the object position. The object position is giving the position of the objects. So since we have each segment is an object, that object position is referring to that single object. When we merge them together, then we have one object, and then the object position is going to be the center, the pivot, which is the position of the first merged actor object or actor, and that means it's only going to have one. So that's why it works for these. So instead of using the object position, what we can do is to try and use what is called the actor position. Actor position in wall space. So I'm going to keep these in here, also the object position actually, just to show what I mean by this. And yeah. Okay. So now these, they still work as they should. And if we turn around, now our procedurally generated tree also works. So we seem to be good now. Everything seems to be fine. We have both the procedurally generated and the static mesh generated ones to be moving independently of each other. So if I take this, just for fun, make it really big and rise up and get our little static mesh, drop it here, and let's set some 1.7, 1.6 something, and then let's just spray a few of these out here. And what you will notice here is that everything looks like it's keeping the same frequency. And this is not really good, because I thought we just fixed it. But the thing is, the actor well position is, our actor position is referring when it's foliage, and it's referring to the actor foliage. And the actor foliage is somewhere in the middle of something, I don't know, 0 something. I can't remember, but I think it's at well 0 position. So that's why they are all having the exact same movement now. So I thought about how we can do this without having to change this, and I'm kind of annoyed that I have to recompile that material function all the time. And also I think we can use this approach for various other things, which I may or may not show, but I will definitely show the end result. And that's by using a material collection parameter collection. So let's make one, call it material function, material parameter collection, tree, sway, swap, sway, swow. Great. Let's move it up here, just to keep all the things in here. Okay, so we want to control a few things we have inside the material function right now. So one of them is the speed. Could be nice to be able to control the speed. We have a speed 1 and we have a speed 2. And we also have a direction 1 and a direction 2. So let's add these 4 values here, and also the strength. All these things, that would be nice to be able to control without having to recompile the material function. So we need one speed and another speed and a strength, and then we need a vector parameter for the direction 1 and the direction 2. So this is speed 1, this is speed 2, and I think we had something like, I don't know, we're going to just come up with some, I don't think it was that anyway, but never mind. And oops, strength, and let's give it 4. And then we have the 2 default. Sway, we had something like 1.5, 5. Okay, let's just give it some values. So let's say 1 and in the x direction, and 0.5 in the y direction. Let's do 0.65 and 1.2, 1.7, 0.7, whatever. Direction 1 and direction 2. So all we need now to do is to go in and switch this out. So it's called a collection parameter, and we can say this is the speed 1. So just replace that one. Do the same down here. Speed 2, the strength, and the direction, and it seems to be just constant B, defaults to const B. I don't know which one is. Oh, this one. Okay, so I need to mask this. Go and mask this to RGB. Is that better? Okay, seems so. Let's copy these two. And pick direction 2. So that means that now we have effectively switched out all the hard-coded values in here. And we, well, the thing is, we haven't fixed that issue with the what do you call it, with the actor position or the object position, depending on if you're using this for the procedural generated one, the static mesh, or as a foliage. So since the problem seems to be the foliage or the procedural one, we can either decide to do a parameter for, or we can't use the same material for all 3 types at the same time. I mean, I can't really figure out how to do that anyway. So what I'm going to do is to just make a setting here, which I can then switch. And that's going to be a scalar parameter. And for now, I'm just going to call that foliage. And what I'm going to do in here is use a switch. Static switch. No, it's not a switch. No, I do not want to use a switch because that's static. I want to use, actually I just want to multiply this actor position with that scalar parameter I just added. It's called foliage. So that means if I set this to 0, that means I want to say 1 minus. And for the other one, for the object position, I'm going to be saying multiply the object position by that without the -1. And then I'm going to add these two together. So only one of these are going to return something really, and that's the idea behind this. So I hope that made just a little bit sense. Okay, so we just let this compile. Okay, and if we then switch to the parameter collection and say foliage, I want to use this for foliage. Then we can see that it's working for the foliages because they are now moving kind of independently. So they don't all sway in the same way. The static mesh, they also work. They move independently of each other. And the procedurally generate is fucked. But since we don't really need that one, because we don't want to have them in our level anyway, then it doesn't matter. But in case we are just working on some of these procedurally generated trees and we're just testing things out, then we can just use this very conveniently to set to 0. And then it's going to work here. And then obviously this is not going to work. They're going to be swaying the same way. Okay, so I hope this demonstrates how we can use the material parameter collection for something interesting. They can be used for all kinds of crazy cool stuff. Like we can do force push, because we actually have the direction in here, and there's no problem. Actually, we can have a position here, and we can use that in the material to calculate the direction we want to use, and so on. So we can actually do quite a few things with these parameter collections here. But I think this is kind of out of the scope for this type of stuff I want to do here. If I decide to do it anyway, it's just going to be, I will demonstrate how I did it. I'm not going to go through the whole process. But I hope this gives a few good ideas of how you can use this. So you can see also we can set quite easily set the strength of this. So we want to affect this like so. And I added an ExponentialHeightFog actor here. That's going to create this really nice scene. Except that I forgot to apply the material, it seems. Yep. There we go. I'm just experimenting a little bit with stuff here. But yeah, still allows you to get close up and see the things clearly, and yeah, I think it's pretty cool. Hello, anybody out there? Hey, there we go. Anyway, guys, I hope you have enjoyed this as much as I have. This has been a really interesting journey for me to do this kind of procedural trees stuff. It was really cool to try something different for change. What I'm gonna do is maybe to put this up for download somewhere. I'm thinking about putting it on Gumroad. In order to do that, I need some of my own textures, and I've been out in the woods to take some pictures. Some tree bark here I'm gonna be using, and had some pictures of leaves and stuff I've been taking pictures of. So I'm gonna crop them up and make sure that you can see I did it with this one. So I'm gonna put a few of these in, do some planes, do some leaf planes and so on, as you've seen me do in one of the other videos. So I'm gonna make a little pack of some of the custom stuff that we've seen in these videos here, just with my own textures here. Oh yeah, and found this beautiful log here, which I also had to take some pictures of. So nice textures, and that didn't turn out so well. That was way too much light, so it's kind of a failure. But yeah, I hope to be able to, oh yeah, lots of nice inspiration. Actually, I forgot to do roots. That's something I completely forgot about. It's fairly easy to add it, but then again, it's gonna take a bit of time to do it. If I decide to take this up again, I might add roots, but I'm not really sure. I need to change topic and do something else. So anyway, yeah, hope you enjoyed as mentioned, and bye for now.